set up here on YouTube stream. How's everyone doing today? Refresh. YouTube. Hmm. We'll get started here shortly. Just making sure streams are good. Okay. We'll get started here shortly. Just making sure streams are good. All right, so I have some real FE practice problems for us to go through. So let me go ahead and pull that up on my iPad. If you're joining today, feel free to drop your name and where you're joining from in the chat. If you are joining on TikTok, you can actually head over to YouTube where I'm also streaming live, just so that you can see my screen as I work through practice problems. I'm gonna start sharing my screen. Hey Cole, thanks for joining. Um, TikTok doesn't let me stream my iPad, so if you actually want to join on YouTube, you'll be able to see me work through practice problems, and you'll be able to see the practice problem on your screen. Hello, everyone. If you're joining on TikTok, go ahead and hop on over to YouTube live, and we will start working through some practice problems together. I hope everyone's day is going well. So for YouTube, if you jump over there, if you just search degree to PE, it should be the first channel that comes up. And once you click on the channel, it should show you the live stream. Let me see if I can share it in the chat. Copy to clipboard. And this session will also be recorded, so if you miss anything, you can always go back to Degree to PE on YouTube and watch our previous live sessions, but really happy y'all could join today. Looks like we have 4 people on YouTube, so that's good. Okay, link. How can I copy it? Oh, okay. Actually, I'm gonna share this with my phone and hopefully that will work. Anyone taking their FE anytime soon? Nice. Thanks for joining from TikTok. Um, Happy you found the page. I'm going to try to share the YouTube live link in the TikTok chat. Just bear with me for a second. Oh my goodness. And we will get started here shortly going through practice problems. So if you don't already have the FE reference manual next to you, a calculator, a paper, something to write with, go ahead and get those so that you're prepared. Okay, back to TikTok live so I can paste the link in the chat. Now, how do I get to the chat? Okay, bear with me 1 second. Comment. Okay, pasting the YouTube live link in the TikTok chat. So anyone joining on TikTok, make sure you hop over to YouTube live so you can see my screen. And with that, I'm going to go ahead and start working through practice problems. So really excited that you all could join today. I hope that this session is helpful for you. I'm going to record today's session so that we can go over it. So that if you aren't able to join today at this time, you can always come back and watch, or if you have to hop off early or something like that. I'm going to go ahead and start recording. And then for some reason, whenever I do the live, it forgets what my iPad is. Video capture device, iPad, okay. Oh, just took a while to pop up, I guess. It's bigger. So I also do do one-on-one tutoring. So if anyone's interested in that, feel free to, I think I did record the last one, but it's only 34 minutes long. But if you go to the D2P YouTube channel, you should see that video from, it says 5 days ago. So yeah, hopefully you're able to find that. Now that I have my, let's bring this to the top. Okay. Guess I'm gonna have to move the question down so y'all can see. Okay, but you all should be able to now see me sharing my screen. My photo's kind of blocking it, so let me move that. But yeah, today I have 3 practice problems for us to go through. The first one is an engineering economics problem. The second one is a surveying problem. And the third one is a fluid mechanics problem. Someone did request that I basically provide you all with the blank worksheet before the live session. So I will definitely try to do that in the future. And I can paste the blank version of this PDF on a Google Drive and provide the link in the description box of this video, but that'll be after today's session. But definitely going to try to make those worksheets for y'all so that you have good material to help you study for the FE exam. But yeah, happy you all could join. I'm Simone. I'm your tutor. So let's go ahead and get started. So practice problem number 1 is an engineering economics problem. Engineering economics should be a relatively easier subject on the FE exam. So you really want to make sure that you can easily get these points. These questions don't take a long time to do as long as you know the information that you're given in the problem statement and what it is that you are looking for. So this practice problem says a company is evaluating a project with an initial cost of $20,000 and an annual benefit of $5,000 for 6 years. If the interest rate is 10%, what is the net present worth? So whenever I encounter an engineering economics problem, I want to make sure I have a good understanding of it. And if engineering economics is not your strongest subject, I'd recommend you do the problem this way as well. So first, let's draw out what this looks like on a timeline, right? So um, I'm going to make a timeline. Each tick mark is going to represent a year. So we have year 1, we have year 2, 3, 4, 5, and 6. Um, we are going to put any values that are, so when money comes out of our pocket, we're going to put it on the bottom side of the graph. So this will be our negative side. And if money is coming into our pockets, we're going to put it on the top side. Okay. So in year 0, um, the initial cost of the project is $20,000. So is that money coming into our pockets or is that money we are spending? It is money that we're spending. So we have a negative value of $20,000 because that's how much money it costs in present day. The question also tells us that after we purchase the project, we're going to earn $5,000 per year. So that is a positive value. So we're getting $5,000 per year each time or after we purchase this device. So let me copy, paste. You guys get the gist. So we're going to see that annual benefit for 6 years. The interest rate is 10%. So the question is asking what the net present worth is. So what does that mean? So this amount that we are, the benefit that we're getting each year for the 6 years, that's an annual amount. So annual amounts in engineering economics are represented by the letter A. A stands for annual. Amount. Okay. And this value that, so the initial cost is a present day cost. So present day costs are represented as P. P stands for present worth. So present worth means how much something is worth in today's dollars. Okay, so the problem gives us an A value and a P value, but it's asking us to find the net present worth. So if it's asking us to find the net present worth, that means we need to convert this A value here to a value in today's dollars, because $5,000 in year 6 is not going to be the same, it's not going to take you as far as $5,000 in year 1, right? Because we know with interest, money loses value over time. So we need to convert this amount to today's dollars. So we need to A, convert A to a present worth value. And then the $20,000, that's already in today's dollars, so we don't need to convert a present worth into a present worth. It's already a present worth value. So that means what the question is asking for, the net present worth is going to equal our A value after it's converted to a P value. So we're going to need to multiply it by some factor to make it a P value. And then we already know we have a negative $20,000 that we spent on this project. So how do you convert A to a P value? If you go to your reference handbook, which I'm going to pull up here on the screen so you all can see. Let me find my reference handbook. It's the PE handbook. I don't think I have the FE handbook handy, but that's okay. If you do have the FE handbook ready, make sure you get that out. But I know the values that I need to know. Let me see if I can actually share it with my iPad. Share. Okay, I'm airdropping it to my iPad so I can show you all how you can use your FE reference handbook to help you solve this problem. So as you can see, I have it open on my iPad. So I'm going to search with the search function, which you're allowed to use on the FE exam. I'm going to search economics, and it's going to take me to this section here, which says engineering economics. And this table is showing you all the different factors that you can use depending on which case you're given in the practice problem. So to convert our A value, remember we're converting our A value to a P value, so we have two present worth values, so we can satisfy this equation here. So to convert A to P, we need to multiply it by a certain factor to make it a P value. So we're going to use this equation here. So see how it says 2P given A? So we were given A, but we're trying to get it to a P value. So we need to multiply A by P over A using the interest rate table and the number of periods that we were given. So going back to the practice problem, we're going to need to multiply A by P over A. And you know it's the P over A value because if you multiply these, they cancel. The A's cancel, right? And you'd be left with P. All right. So we're going to multiply by the P over A value. Our interest rate is 10%, and our number of periods is 6. All right, so we have our equation set up. So our net present worth is going to equal A P over A, 10%, 6 periods. Subtracting the initial cost. Okay, so what is the P over A value? Again, you want to use your engineering reference manual to determine that. So we're going to go to the interest rate table of 10%. There's a lot of interest rate tables in here, so make sure you grab the right one. This one is 10%. So we are going to find, it's kind of big. Okay, so we're trying to convert A to a p-value. We're going to have to multiply it by P over A. Our number of periods is 6, right? Because it's 6 years. I don't know why this is so large. Okay, 6. So we're going to go to where 6 and P over A intersect. We're going to get 4.3553. Does that make sense to everyone? Okay, so going back to the problem, 4.3553. So this equation becomes, what is A? A is going to be the uniform annual amount, so that's going to be $5,000. 5,000 times that factor we just got from the table, which is 4.3553. And then we need to subtract the initial cost, which is $20,000. So what would the net present worth be? So if you're following along and you have your calculator, you can go ahead and try this out. So 5,000 times 4.333, 4.3553 minus 20,000. Anyone have an answer they want to share in the chat? I have an answer. Do you have an answer? Give y'all a second. So you should be getting a positive $1,776.50. So that is our net present worth. And what that's saying is if we did not, instead of getting the $5,000 each year as a benefit, if we got all that money in today's dollars, that would, and we subtracted the initial cost, the $20,000, we would be up $1,776.50. So a good investment because you're earning money on it. But yeah, that's our engineering economics problem. Let me know if you all have any questions. Otherwise, we're going to move on to practice problem number 2, surveying. Everyone's favorite class, right? Did you guys take surveying freshman or sophomore year? You guys remember taking surveying? It's a pretty fun class. I went to Iowa State, and I took it in the fall semester, and we actually surveyed outside. It was very cold, but we got it done. We got it done. Okay. So I hope you all are with me here. We're going to get started on practice problem number 2, surveying. So the question says a line of sight is established between a level instrument and a staff held on a benchmark of elevation 100 meters. Ooh, I'm gonna sneeze. Okay, we're good. Okay, the back sight reading is 1.5 meters, and the foresight reading on the point is 2.2 meters. What is the elevation of the point of interest? So I did this practice problem with my tutoree yesterday, and I did not find surveying equations in the reference manual. I'm probably gonna have to go back and check. I think there's probably equations that you can use for this problem in the transportation engineering section, but um, this is a very basic, simple surveying problem, so I'm not going to go search for it, but I will try to pull up a photo so you all have a visual representation of the math that we're doing in case you haven't taken surveying yet or you just need a refresher. Surveying, backsight, foresight. I found a really great picture yesterday. So let me go ahead and paste that. Okay. Can you all see this? I hope so. So yeah, this gives us a visual representation of what's happening. So BS is backsight. So we have our backsight here. BM stands for benchmark, which is just a point that in construction, benchmarks help the contractor. It basically gives them a base point for elevation, their X coordinate, their Y coordinate, just so they can construct everything that they need to construct to one level. FS is foresight. Foresight. And TP is going to be our point of interest. And this picture also gives you very handy surveying calculations down here. So it says the benchmark, the elevation of the benchmark plus the elevation of the backsite equals the elevation of the level, right? So you have the elevation of your benchmark, you're going to add this distance here, and you're going to get the height of your level. So let's go ahead and do that. Our benchmark, so we're going to do our benchmark plus our backsite equals the height of our level. So the benchmark elevation is 100 meters. Our backsite elevation 1.5 meters. So that's going to be 101.5 easy math meters. Again, this would be a gimme on the FE exam. So if you have any questions, feel free to ask them in the chat. If you're joining on TikTok, I dropped the YouTube Live link, so go ahead and use that to come over to YouTube Live so you can see my screen and the practice problems. Thank you all for joining on TikTok, but you can go ahead and hop on YouTube. So now that we have the height of our level, now we're going to use the second equation here. So we're going to use the height of our level. We're going to subtract the foresight distance, and that's going to give us the TP elevation that the question is asking for. Okay, so we have the 101.5. What's the foresight elevation or reading? It's 2.2. 2.2, and that is going to give us what? Anyone want to do the quick math? Drop the answer in the chat. I did this yesterday and I'm still using my calculator because your calculator is a tool. There's no need to do mental math when you can make sure your work is exact and correct on this FE exam. Use your calculator. That's what it's there for. So I'm getting 99.3 meters, which is going to be the answer to this question. Yay! Super simple, super easy. We will do more surveying practice problems in the future. I will be releasing a course eventually that goes through each of the modules. So yeah, don't worry if you had any troubles with this. Feel free to message me also on LinkedIn, Instagram, TikTok, YouTube if you need help. You can also submit practice problems. I forgot about that. I did create a link so you all could submit any practice problems that you want me to go through. Go ahead and look at that going live video that I posted. Let me check to see if anyone submitted any. No one submitted anything, but that's okay. I have plenty of practice problems for us to work through. All right, but that is all for practice problem number 2. We'll go ahead and move on to practice problem number 3, which I'm a civil, but my work has mostly been on the water side. So we're gonna get into some fluid mechanics. If you hate fluid mechanics, I'm going to try to change your mind. Um, this is a very simple fluid mechanics problem, so don't get scared. We're gonna get through this together and we'll keep compounding on this. So in today's problem, we're going to go over very basic concepts of fluid mechanics, and hopefully that'll give you some confidence to keep working through fluid mechanics problems. Um, the person I'm tutoring right now, fluid mechanics was not his best subject, so I'm definitely working on developing a worksheet and a module for fluid mechanics. So yeah, practice problem number 3 says a horizontal pipe carries water at a velocity of 2 meters per second with a pressure of 300 kPa. The pipe narrows to half the cross-sectional area. Assuming incompressible frictionless flow, what is the pressure in the smaller section? Again, if you are joining on TikTok, go ahead and hop over to YouTube Live so you can actually see my practice problem. I dropped the link in the chat, but let me know if you guys are having any issues. You can also just search for Degree to PE on YouTube. And make sure you guys are interacting, comment in the chat, like. There's a lot of engineers here, so it's a great networking opportunity just to see where everyone's from. Everyone's obviously trying to pass their FE exam, so maybe these can be study buddies for y'all. All right, but let's get into this practice problem. So we are talking about pressurized flow through a pipe. I'm going to go ahead and draw what this looks like. So we have a pipe, and then it narrows to a smaller pipe. All right, let's get a break line in here. Not the best break line, but you get it. So one thing about pressurized flow, and this again, this is a very basic concept. So if you get any conceptual questions, that's where we're starting. So when you have flow going through a pipe, and flow is denoted by the letter Q. Q means flow rate. And flow rate can be you're going to have a volume at a certain speed. So it's going to be like meters cubed per second or feet cubed per second. That's what your flow rates look like. Okay, so the flow through a pressurized pipe is going to be the same no matter what the cross-sectional area is. So Q, flow going through this point right here, let's call it point A, and this point right here, point B, they're going to be the same. So Q1 is going to be the same as Q2. Um, Actually, let me back up a little bit. Flow rate. Flow rate again is going to be Q, and Q is equal to area times velocity. Okay, so usually CAV. And again, we just said Q1 needs to equal Q2 because the flow is going to be the same in a pressurized pipe no matter what the cross-sectional area is. So if you have less area, like you do at point B, so let me write this, A1 times V1 is going to be equal to A2 times V2. So the cross-sectional area is decreasing. So what does that mean is happening to the velocity? Sorry, trying to move my camera out of the way. Okay, so if the area decreases, but Q1 needs to equal Q2, what does that mean is happening to velocity? So to keep Q1 proportional to Q2, if A2 is decreasing, that means the velocity needs to be increasing. Okay, so in this problem statement, it says that the pipe narrows to half the cross-sectional area. So we have A1 divided by 2 is going to equal A2. Okay, so let me scroll down. Hopefully you all have the notes that you need. So just scrolling down a little bit. So yeah, the problem statement says the cross-sectional area narrows to half the narrows to half. So that means A2 is half of A1. So let's go ahead and plug this into this equation and see what we get. So we're going to have A1 times V1 is going to be equal to, A2 is equal to A1 divided by 2. A1 divided by 2 times V2. Hopefully you all can see that. So the A1s will cancel because if you divide both sides by A1, you're not going to have an A1 anymore. Okay. I love using color. I hope color is helpful to you all. So the A1s cancel and you're left with V1 equals 1/2 of V2. So if the velocity if the velocity V1 is 2 meters per second, which is given in the problem statement, we have 2 equals 1/2 V2. So what is V2? What is V2? So we're solving for V2. We're going to get V2 equals 4 meters per second. So even without knowing the area of either sections of pipe, we can still find the velocity going through the smaller cross-section of pipe. So we have V2, we have V1, and the question is asking us about pressure. So does anyone know what equation, and you can use your reference handbook as well, what equation, if you've taken fluid mechanics, you already know what the answer is. There's one or two, really. There's two equations, but I'm looking for one. What equation relates pressure, the different pressures in fluid flow, basically? What equation is that? Anyone able to find that in their reference handbook? Thank you for liking the live. If you're on TikTok, go ahead and hop over to YouTube so that you can see my screen and see the practice problem. But yeah, really appreciate you guys' support. Yeah, it's nice to see so many people in here. Okay, so the equation that I'm asking you all about is the Bernoulli equation. Bernoulli equation. Let me see if I can actually pull this up in the reference manual so we can all look at it together. Okay, let me go back. 1 second. I have so many screens I'm trying to look at. Okay, recent. I keep pulling up recent and like it's not coming up. Let's see. Oh, there it is. Okay. So again, I'm going to search the FE reference handbook. Okay. Again, 1 second, giving me trouble. Come on, open, open, open. Okay. So, hopefully you all can see this now. I'm going to search this PDF for Bernoulli, Bernoulli, and see what comes up. Again, you want to make sure that you're also using the strategy on the FE exam so that you can quickly get to the sections of the reference manual that you want to look at. Okay. Can you guys see this? Cool. Okay. So Bernoulli's equation is basically the energy equation for incompressible flow. So all of these, so in this first equation, let me use a different color. So this is pressure. Then you have the elevation head, and then you also have the pressure from the velocity or the energy from velocity. And we're also given the density of water, so that's good. These are the same. These two equations are the same. They're just written in different ways. But you can actually get rid of gamma on the bottom if you multiply this top equation by gamma, and you'll be left with P1 plus Z1, which in this practice problem, we're not accounting for elevation head because we are assuming, sorry guys, 1 second. Okay, gotta get back to this. We are assuming that both of these points, point A and point B, are at the same elevation. So do you guys see that? So there's no difference in elevation. Let's make it black. Let's make it dashed. Okay, so we're assuming that these are at the same elevation. So we're not going to have an elevation head or any energy from an elevation change. Okay, going back to the reference manual. Nope. Okay. Let me go back. Goodness, having so many technological problems today. All right. So there's no elevation head, so we don't need to worry about that. And then we're going to have V1 squared over 2, I believe. Does that make sense to everyone? So when you multiply by gamma, you are going to have the density on the top. Let me rewrite this. So you're going to have P1 plus 1/2 rho V1 squared. That's going to equal P2 plus 1/2 rho V2 squared. So this is our equation. But if this is confusing for you, you can always just use the equations as written in the FE reference manual. I just did some math to rearrange things to make the equation a little bit simpler. Okay, so I'm going to paste that equation here. Let me make it black. Let me make it red so you all can easily see what I'm doing. Okay, moving myself to the bottom left corner. Don't see any questions in the chats, so I hope you all are understanding. So also in this equation, we need to make sure that the units are consistent with this equation. So we're given P1. Can anyone tell me what P1 was? We had P1 is 300 kPa, but we actually need it to be in just Pascal. So it's going to be 300. If there's a K, you just add 3 zeros at the end. So we have P1, we have V1, which is 2.0 meters per second. And yeah, we're given the density of water, which is 1,000 kilograms per meter cubed. So we're going to be able to solve this side of the equation. We found V2 to be 4 meters per second. Again, we know the density of water already. Changing colors here. Okay. But we don't know what P2 is, and that's what the question is asking us for. So we're solving for P2. So let's go ahead and do that. So we're going to have 300,000 plus 1/2 times 1,000 times 2 squared. Don't forget to square it. Those are very easy mistakes to make on the FE exam. So yeah, if you need to, write it out or make sure you're typing it correctly in your calculator. We don't know P2, but we do know that we're going to multiply 1/2 by 1,000 times 4 squared. It's my dog. Okay. So yeah, let's solve for P2. Let me know what you guys get in the chat. So on this side, I'm getting 302,000 equals P2. Let's see, 1,000 times 4 squared divided by 2. So I'm getting plus 8,000. If we subtract 8,000 from both sides, we can solve for P2. Anyone want to give the answer in the chat? I know there's some lag between my live and when you all see it, so I'll just wait a little bit. Don't be shy. Feel free to give the answer. 302,000 minus 8,000. We're going to get P2 equals 294,000 pascals. But if we want it in kilopascals, it's going to be 294 kPa. How was that for everyone? Did that make sense? Does anyone have any questions over any of the practice problems that I went through? This is the last one that I have for you, so get your questions in now. And then if you are feeling too shy to share on the live, again, feel free to message me on LinkedIn, Instagram, TikTok. This should be recorded and posted after today's session. If there's any topic that you guys really need help with that you want me to go over in the live session, let me know. I want to make sure that I'm getting you all the practice that you need. So if you know that construction engineering is not your best subject and you want me to do some construction engineering problems, just let me know. Otherwise, I'm going to keep picking random topics pretty much. This was a set I did with my tutoree yesterday. So I'm just reusing that material. But if you guys want me to focus on a certain area, I can definitely do that because I want you guys to pass. I want you to feel confident. So yeah, just let me know. All right, that's all I have for you guys today. It was great seeing you guys. Tomorrow I'll be going live again from 3 to 4. Share with your civil engineering friends. And yeah, have a good rest of your day. Bye.